G'day, I'm Dr. Kev, and we've been designing a sports car inspired by the 1950s. And one of the things I love about classic cars are their gauges. But one of the things that's generally not that great about classic cars are their electrics. So I wanted to see, could I take a high-end modern digital dash and give it a little bit of that analog feel? Welcome to Car Design Workshop. While Project 171 is intended to be inspired by the 1950s, I did want to have some modern technology in there. So I got thinking about gauges as they relate to the whole electrical system of the vehicle. And I wanted a solution where the dash and the ECU and maybe the power distribution, so how we are getting power to different parts of the electric system, would work well together. When looking around, there was one solution, one platform that really stood out, and that was using Haltech products. Now, with full disclosure, John Grove reached out to Haltech, and they have decided to support the channel with a generous discount on their products. But please, just keep it between you and me. I would have paid full price for it anyway. Now, I'm going to go into those decisions around the ECU in a later video, but I just want to mention that the Nexus R5 is a data logger, engine management system, and a power distribution module all in one. That made the ECU very, very attractive. So I wanted some gauges that would marry up well with the Haltech solution. Now initially I was looking at completely analog style gauges that would communicate over CAN with the Haltech, and some of these products look pretty amazing, but the price was also pretty eye-watering. So I thought I'd have a look at the Haltech dashes. They were reasonably well priced, but one of the really big bonuses that they have is they have extra data inputs. So there's a number of analog sensor inputs as well as some digital inputs that would be really, really useful when it comes time to develop the car, especially around building some data capability. So if we're doing aero studies, at some point we actually want to get some pressure gauges on the car and measure pressure at different points on the body. We want to be able to mount linear pots to the suspension and see how that's working. And while doing that development, it'd be really good to be able to customize the display a little bit. Maybe show some information while we're testing the car that we wouldn't necessarily want while we're driving the car around normally. So a little bit of customization in a dash would be pretty helpful. So I thought it's worth picking up one of these dashes, even if down the line the car ends up having some analog gauges. Now, a real bonus with the Haltech dashes is it communicates very, very easily with the ECU. It's a simple CAN connection. So a CAN connection, you've got two data wires and you just feed power and ground to the dash, and you've got two-way communication between these devices. And staying in the same family means that the CAN communication protocols, which can be a little bit of a pain in the backside if you've ever done that before, they're generally well sorted out. They're set up to be able to communicate with each other. So I thought it'd be interesting to see if I could make this dash a little bit more of a long-term solution. The dash is more capable, lighter, cheaper, and simpler than a full gauge cluster. So if I could run with it, it's a big bonus. But the problem is, if I'm going for 1950s, a big flat digital screen, that's not a 1950s aesthetic. So from a design perspective, thinking about what I like about analog gauges was pretty important. First, and the most obvious, is that they have depth. A computer screen is flat. I mean, you can put whatever images on that you want, but you're only giving the illusion of 3 dimensions. There isn't actually a third dimension. Where an analog gauge, the needle will be sitting up off a surface. There's shadows there. Another visual issue with a digital dash is that they're never really truly off. When you're showing a black on an LCD style screen, that is actually still putting some light out. There's light bleed. Now on a high quality display like the Haltech, it's not a huge deal. And if I was doing something a bit more of an 80s style or 90s style dash, you could actually really lean into that. But for a 50s dash, even if I was to create a bunch of images that were round gauge style cluster, the rest of that background was going to be feeding light to your eyes. And I just didn't want that. On the big plus side for the digital dashes is you have massive amounts of customization. That means that if I don't like the aesthetics that first come out with a dash cluster, I could change that pretty easily. Now this is the Haltech dash. It's a beautiful product, it's really well built, very, very nice glossy screen. But what you'll notice is that the actual screen in there, the rectangular screen, is inset. So not the whole surface lights up. And another thing is that if we look through the steering wheel, we see that there's actually parts of that rectangular section of the screen that you can't actually see. They're blocked by the steering wheel. That's why with traditional gauge clusters, they're arranged in a way that what you're seeing through the steering wheel displays all of the information. They're very rarely arranged in a rectangular pattern. So there wasn't much I could do about making the needles look 3D apart from a bit of graphic design, but there was plenty I could do to knock out that light bleed and put a little bit of depth into this dash. So what I thought I would try is making a 3D printed cover for the dash to see whether I could build some depth there, as well as blocking out sections of the screen where I wasn't interested in showing any information. Now these are early prototypes, there's a lot more work to be done, but I think they're a really good proof of concept. And this video is being sponsored by JLC 3DP. 3D printing is so valuable for doing custom car builds. We use it quite a lot. We use it in mock-ups, we use it in final use parts, as molds, and so on. And normally I would do most of that 3D printing at home. It's not that expensive to buy a pretty decent 3D printer that uses FDM. Now this particular part was larger than the build volume that I have on the machine that I use at home. And I was actually keen to try a different manufacturing process. So JLC 3DP has a lot of different 3D printing processes using different plastics, metals, and so on. But the one I was keen to try out was the multi-jet fusion method. In my work, I've seen this technology used before, and it produces really good enclosures with really good texture, and you just don't see any layer lines. So to start this process, I needed to work with the original model of the Haltech UC10. Haltech provide an STL of that dash, which is really, really helpful. But I did need to go through and add a couple little details and create a new model from that. In particular, I wanted to make sure that I knew the area of the screen. I wanted to pretty much block off everything that wasn't part of that screen, and even part of that screen, as you'll see, we lose the edges of. I also wanted to make sure that the light sensors were well accounted for. So these are sensors that are used to determine are we running in daytime or nighttime, and can change the brightness of the screen automatically. I also needed to be careful that I was ensuring that I was keeping access to the USB port for programming and so on. So the STL supplied from Haltech was very, very useful, but I ended up making my own model based on that. Now at this point, we already have a mock-up of the car, so we can sit in this mock-up, look through the steering wheel and see how much of the dash we can see. So using a CNC router, we did the outside profile of the Haltech dash, and we could mount that behind the steering wheel to get an idea of how much was visible and not. We also followed that up by doing that in the CAD package. So in SolidWorks, put a camera located where the driver's head would be, pointed it down towards the steering wheel, and we can get an idea of the available shape. So we see on this cover, this curved part here indicates the area that you can actually see looking through the steering wheel. This cuts a small amount of the upper corners of that viewable dash out. From there, I wanted to work with what's the most important bits of information. So we have the RPM, knowing what your engine is doing on a performance car, absolutely the most important. Put that central, as large as we could make it. And then off to the side, a speedo, and then on the left-hand side, a sort of a multi-gauge cluster where we could look at fuel level, battery voltage, oil pressure, and water temp. It did leave a few areas there where we could put indicator displays as well as warning lights. Now on this particular prototype, I haven't put a huge amount of depth. I've really only added about 5 millimeters of depth to it, but I wanted to sort of block out the center section of each of the gauges. This is where the needle would have a raised section, and I felt probably the place where the lack of 3D in the needle would be most notable. So I just wanted to block that off. And that creates a little bit of a manufacturing issue because there's not a lot of support there if we want to keep most of the gauge visible, and these are reasonably thin sections. So when we're working with JLC, what you would do is you would upload an STL of this model. They can take a few different formats there, but I found STL to be a fairly reliable one to get out of SolidWorks and into their software. And then you go through and specify what is the technology that you want to use as 3D printing, what's the material, what's the style of finish, and so on. They give you a quote that includes shipping, and I've got to say, these are reasonably inexpensive parts for the technology you've got access to. Different 3D printing technologies cost different amounts, but the multi-jet fusion is more expensive than an FDM, but it's also more expensive equipment. It's equipment that's really outside of what you would expect to be able to have in a home workshop. And when I sent this off to get made, I got some immediate feedback, and they were concerned that some of these sections were too thin. If you do fairly large parts like this, or flat surfaces like this, it's difficult not to end up with a little bit of warping. So with that feedback, I went back and actually made a few changes. I made it slightly thicker, which I think ended up with a better design, and also took the opportunity to take some weight out of this, I guess, this sun visor section that I have here. A little bit of shade so that I could make sure that you're not getting absolutely bright sunlight on those surfaces. I was able to just go back and hollow that out. Should have done it in the first place. When the second version got uploaded, I got the feedback that it was much better. There was still some concern that there might be some warpage, but given the part that I was making, I just had to accept that risk. And so I said, yeah, let's go, let's print it and see how it is, and taking a little bit of a gamble. I wasn't entirely sure how good the product was going to be. Once I'd approved the part, I thought I'll be able to sit back, work on something else on the car. It's going to be a little bit of time before this arrives. I was incredibly surprised when, I think 3 days later, the part had arrived on the doorstep. In the meantime, I was actually keen to get on and see whether the dash was working. And John Grove, who in his business provides some 3D printed components, actually had a bigger 3D printer, an FDM printer that I could use, and offered to print out a sample. So I've actually got two of these. The one that John made is an FDM, and it's made of ABS. And as soon as I put it on the dash, I immediately was a bit excited. That 3D appearance, what I was just giving a shot, was immediately apparent. And frankly, probably would have been okay with running this FDM thing on a final car, at least at the start. Now the one from JLC 3DP, that was a MJF, so multi-jet fusion method, and it's made of nylon. So both materials are fine. They both have advantages and disadvantages when you're using them. ABS is absolutely fine to run in a car. It can be a pain to print with at times, but not as difficult to print as a nylon filament. So I've had some issues in the past printing with nylon, but nylon's a really, really nice plastic to use. And when this thing arrived, I was blown away by the quality. It's really hard to show just how different they are on the camera. The FDM, the ABS one, shows the layer lines. If you've had anything to do with 3D printing, layer lines is something that you live with. It's not necessarily a bad appearance. There are some things that you can do to work around it, especially with ABS. You can use some acetone and smooth that surface out, or you could go through and actually paint it, do that whole prep. But when you compare it to the nylon product from JLC, this is just uniform. It's a fantastic texture. It looks like a part that has come out of an injection molding process or something like that. It's immediately a final use product. The ABS one, if you move it around in light, you see the light bounces off in funny ways. You'll notice some parts are matte, some parts are a little bit glossy. But with the part out of nylon, it's so uniform in its texture. And it's just, as the light goes over it, it's just gorgeous. And these little details, this attention to detail is the sort of stuff I love about cars. So while I was just trying to test out this technique and to see whether it was usable, I was absolutely blown away with the quality. And for the price, absolutely fantastic. Now I'm getting sponsored by JLC, so I didn't have to pay for this, but having seen the quality, I would have had zero hesitation in paying for it. Even though I think it's going to be a couple of iterations before I'm absolutely sold on the design. So now I had a cover that works pretty well. And because I had 3D printed it, I was able to output the DXF of that gauge cluster into some graphics editing software. I've had viewers in the past mention open source software for things like 3D modeling and so on. I haven't quite gone there yet. I've got easy access to SolidWorks. But as an engineer, I don't have access to a lot of the graphic design software. So I actually use open source software quite a lot when I'm working with images. My two favorite ones to work with would be GIMP when I'm looking at the final image. And if I want something that is working with DXFs, I'll use Inkscape. So I exported the DXF, opened it up in Inkscape, and I could play around with the dash background. Now, one of the advantages of the Haltech solution is that you can change this pretty easily. Now, I hadn't used the Haltech NSP software before, but I found it fairly straightforward to use. Pretty interested that the one piece of software is used to set up both the ECU and the dash, so I can stay in that one environment. It's fairly easy to add gauges as you want, as well as indicator lights and warning lights and whatever you'd like to do, as well as any images that you want. So I mainly worked on developing a background image as well as a mask to cover over anything that I didn't want shown. It's pretty easy to hook these gauges up to whatever data stream is coming through, and that data might be coming from CAN, or you can get something like an adapter and actually pull the data from an OBD2 port of a car. Now, ultimately, this is going to be communicating through CAN with the Nexus R5, and there was an evening where Harley and I were working in the workshop and we thought we'd get the loom, an R5 and the dash, and we could spend the evening getting it to work. We had it working as soon as it was plugged in. It was amazingly easy to put together, plug and play, exactly as I'd hoped, but didn't imagine it would actually turn out that way. So I'm very, very impressed with Haltech's product in just getting it up and running. But we also wanted the ability to be able to test the dashes and test the different arrangements when it's not hooked up to that ECU. So Harley went away and built a bit of an input box. And this was using just some of the analog inputs on that UC10. So we just had 4 switches where we could look at things like if we were pressing an indicator, as well as a rotary pot or variable resistor to be able to input a speed or RPM or a temperature or fuel level and actually see that moving on the real dash. There is the capability to do a graphic simulation of that in the NSP software, but given that we're working on aesthetics here, wanted to see all of that lit up with the cover for real. Anytime that you're able to bench test your electronics is a bit of a bonus in my opinion. And that's about where we're up to right now. There's a little bit of work we still want to do as the car's evolving. I'd imagine that we're going to have another go at the 3D printed cover and maybe looking to try and sneak some different materials in there. We've definitely got a lot more work to do when it comes to the actual display in the background. I'm not a graphics designer. Those things take me a little bit of time to get it close to what I want from an image. But overall, very, very happy with how it's turned out. It's not quite the same as running analog gauges, but I can see the potential there that we can have a lot of the aesthetics from that analog look and a lot of the capability of these modern electronics. Now, for those of you that are already signed up to the Patreon, we did show some of this a little bit earlier, and we have uploaded the STL of the 3D printed cover that was first sent off to JLC 3DP. And once we've sorted out the Haltech UC10 file completely and a bit further along, we'll look to upload that as well. If you do want to support the channel directly, please feel free to sign up to the Patreon. We generally show things a little bit earlier there, just as we've got work in progress. And we're trying to include a little bit more of some of the documents and so on that we're using in the development of this car. Otherwise, please feel free to continue following us on YouTube. As always, I'm really keen to hear your feedback here. I know anytime we're talking about the aesthetics of the car, it tends to drive a fair bit of discussion. And I know some of you may be disappointed that it's not going to be analog everything, whereas some of you are going to be incredibly happy that I'm not completely stuck in the 1950s. If you want to see more of how this project is developing, subscribe to the channel. We've got a lot of things that we're working on at the moment, and there's videos in the works. There's a lot more stuff coming your way on this channel. Thanks for your time.